Hello everyone. Welcome back to Prince of War channel. The T-38 Talon is a twin-engine, high-altitude, supersonic jet trainer used in a variety of roles because of its design, economy of operations, ease of maintenance, high performance and exceptional safety record. The T-38 has swept wings, a streamlined fuselage and tricycle landing gear with a steerable nose wheel. Two independent hydraulic systems power the ailerons, rudder and other flight control surfaces. Critical aircraft components are waist-high and can be easily reached by maintenance crews. The T-38C incorporates a glass cockpit with integrated avionics displays, head-up display and an electronic, no-drop bomb scoring system. The AT-38B has a gun sight and practice bomb dispenser. Air Education and Training Command uses the T-38C to prepare pilots for frontline fighter and bomber aircraft such as the F-15E Strike Eagle, F-15C Eagle, F-16 Fighting Falcon, B-1B Lancer, A-10 Thunderbolt and F-22 Raptor. The T-38 can be traced back to 1952 in Northrop's N-102 Fang and N-156 fighter aircraft projects. During the mid-1950s, Northrop officials decided to adapt the N-156 to suit a recently issued general operating requirement by the United States Air Force (USAF) for a supersonic trainer to replace the Lockheed T-33. The bid was successful, in no small part on its lower life cycle cost comparisons to competing aircraft, and the company received an initial order to build 3 prototypes. The first of these, designated YT-38, made its maiden flight on the 10th of April 1959. The T-38 was introduced to USAF service on the 17th of March 1961. The USAF is the largest operator of the T-38. Additional operators of the T-38 include NASA and the United States Navy. U.S. Naval Test Pilot School in Patuxent River, Maryland, is the principal U.S. Navy operator. Other T-38s were previously used by the U.S. Navy for dissimilar air combat training until replaced by the similar Northrop F-5 Tiger II. Pilots of other NATO nations have commonly flown the T-38 during joint training programs with American pilots. The T-38 remains in service as of 2023 with several air forces. As of 2023, the T-38 has been in service for over 60 years with the USAF, its original operator. In September 2018, USAF announced the replacement of the Talon by the Boeing Saab T-7 Red Hawk with phase-out to begin in 2023. The Northrop T-38 Talon is of a conventional configuration, with a small, low-mounted, long-chord wing, a single vertical stabilizer, and tricycle undercarriage. The cockpit accommodates a student pilot and instructor in a tandem seating arrangement. The flight controls were hydraulically powered and lacked manual reversion, and thus the aircraft would be unflyable in the event of both engines failing mid-flight. Its handling was relatively conventional and viceless. While it was originally considered to be too easy to fly compared with frontline fighters of the 1960s, by the 21st century, it had become regarded as the most challenging aircraft in the USAF's inventory. The aircraft's nimble performance earned it the nickname, White Rocket. It had been considered by trainee pilots to be a somewhat unforgiving aircraft from an aerodynamic standpoint. The T-38 can be visually distinguished from both the F-5B and F-5F, which are also derived from the N-156, by the wings. The wing of the T-38 meets the fuselage straight and ends square, while the F-5 has leading-edge extensions near the wing roots and wingtip launch rails for air-to-air missiles. The wings of both the T-38 and the F-5 family use conventional skin-over-spar rib structure. The T-38's wings were originally designed to withstand 7.33 G loads and for a fatigue life of 4,000 flight hours. This proved sufficient for the majority of the training syllabus, but was a major limiting factor when the aircraft was used for aggressive dogfighting-style maneuvering. Incidents of wing tips separating mid-flight were reported. Northrop resolved this via the installation of new wings with thickened skins. Throughout the development process, a strict weight control regime was exercised by the design team. This was one reason for the T-38's relative simplicity. Only basic systems for navigation and communication were provided. No fuel was housed within the wings while no provision for external stores was made. The aircraft's twin General Electric J85-5A turbojet engines were accommodated within the fuselage to exert less drag and produce fewer aerodynamic disturbances. The J85-5A engine, despite generating up to 3,850 pounds of static thrust, was relatively compact and lightweight for the era, weighing less than 600 pounds. Air was supplied to the engines via intakes at the wing roots. A twin-engine arrangement had been pursued to provide a greater margin of safety. Various design decisions were taken and features were incorporated to simplify the T-38 and make it as easy to maintain as possible. To avoid removing the vertical fin while changing an engine, the fin was attached directly to the keel structure between the engines, and instead detaching the horizontal stabilizer along with the entire aft shell of the fuselage that surrounds the engines, which could be removed relatively easily via undoing several fasteners that hold the fuselage shell together and disconnecting two push rods that connect the pilot's control stick to the horizontal stabilizer's hydraulic actuators. To avoid having to break and reconnect multiple hydraulic lines during an engine swap, designers mounted the hydraulic pump and other accessory drives on the fuselage which joined to the engine by a short drive shaft. Several internal check valves prevented a loss of hydraulic fluid. The engines hung from rails on either side of the central keel. This design enabled ground crews to remove and replace an engine in roughly 1 hour. In 1952, Northrop began work on a fighter project, the N-102 Fang, with shoulder-mounted delta wing and a single engine. The proposed General Electric J79 engine, weighing nearly 2 tons, meant the resulting aircraft would be large and expensive. During 1953, representatives from General Electric Aviation's newly created Small Aircraft Engine Department showed Northrop a relatively compact engine, around 400 pounds installed weight, capable of 2,500 pounds of thrust. Upon seeing the engine, Northrop VP Engineering Edgar Schmood saw the possibility of reversing the trend toward the large fighters. Schmood and Chief Engineer Welko Gazik decided on a small, twin-engine, hot rod fighter, the N-156. Northrop launched its N-156 project in 1954, aiming for a small, supersonic fighter jet capable of operating from the U.S. Navy's escort carriers. When the Navy chose not to pursue equipping its fleets in such a fashion, favoring large fleet carriers instead, Northrop opted to continue work on the N-156 using in-house funding. It was instead recast as a lightweight fighter, referred to as the N-156F, that was primarily aimed at the export market. Most of the USAF's aircraft, T-38A and AT-38B, have been converted to the T-38C through an avionics upgrade program. Improvements include the addition of a head-up display, global satellite positioning, inertial navigation system, and traffic collision avoidance system. Most aircraft have received a propulsion modification to improve low-altitude engine thrust. Around a third of the fleet, those that experience more severe usage, are currently undergoing structural replacements and upgrades, as well as receiving new wings, to extend their service life to 2029. The fighter version of the N-156 was selected for the U.S. Military Assistance Program and produced as the F-5 Freedom Fighter. Many of these have since reverted to a weapons training role, as various air forces have introduced newer types into service. The F-5G was an advanced single-engine variant later renamed the F-20 Tiger Shark. In 2018, the Iranian Air Force announced that an outwardly similar aircraft, named the Kosar, had been constructed within Iran. Thank you very much for watching this video. Don't forget to support this channel by liking and commenting on your opinions here. See you in the next video.